Hello class 7. We will continue with electrolysis. Today we will talk about we will start with the electrolysis of lead bromide. Okay, we will study the electrolysis of lead bromide. As you can see the diagram over here, this is the silica crucible. Okay, this is the silica crucible made up of silica, of course. Why is silica used? The electrolytic cell is made up of silica crucible. Why silica? Because it's non-reactive, it withstands a very high temperature and almost a non-conductor of electricity. So that is why the electrolytic cell over here is made up of silica in the electrolysis of molten lead bromide. Now, why molten lead bromide? Why molten? Why not solid? Because lead bromide is an ionic salt made up of which consists of electrovalent bond between lead and bromine, and very strong electrostatic force of attraction will bind lead and bromide ions together. That means the ions are not free. So since ions are not free, we use it in a molten state to show that lead bromide dissociates into ions Pb2 plus and 2Br minus. Now the ions in a molten state, ions are the lead bromide ions are now free, lead ions and bromide ions. And solid lead bromide do not conduct electricity because the ions are held together by the very strong electrostatic force of attraction. Very strong electrostatic force of attraction will bind the ions together. So therefore, lead bromide in a solid state do not conduct electricity. So it will conduct electricity in a molten state, in a liquid form. Okay. So now we have another thing you have to remember are the electrodes. What are electrodes made up of? In the electrolysis of molten lead bromide, the electrolyte, the anode, is made up of graphite. Okay? And the cathode is, of course, they are inert electrodes. So anode is made up of graphite, whereas cathode is made up of either iron or graphite. Both are inert electrodes. Okay? Now, the temperature at which lead bromide will melt is 380 degrees Celsius. That means the electrolyte in the electrolytic cell is in a molten state, it's hot, 380 degrees Celsius. And the current given is 3 amperes. Now we already know that lead bromide in a molten state, this is lead bromide in a solid state. When it's molten, it dissociates into free ions that are mobile. They will move around within the electrolyte, Pb2 plus and 2Br minus. Now, what will happen? You already know that since it is made up of lead, and since the electrolyte has lead ions and bromine ions, lead ions will migrate towards the cathode. Pb2 plus will migrate towards the cathode, and Br minus will migrate towards the positively charged anode. Positively charged lead ions will migrate towards negatively charged electrode, whereas negatively charged bromide ions will migrate towards the positively charged electrode, that is the anode. That means the cations will go to the cathode and anions, negative ions, will migrate towards the anode. You know, opposite charges, they attract each other. So now, you got to remember the reaction at the cathode. Now what happens? Lead is attracted lead in the electrolyte, the molten lead, PbBr2. PbBr2. The ions of lead will migrate, since it is in a molten state, now they are free. Lead ions, Pb2 plus, will migrate towards the cathode. And now what happens? Since lead ions are deficient of 2 electrons, it is positively charged, isn't it? It is positively charged. To become lead metal or lead atom, this lead ion needs 2 electrons. It needs 2 electrons. So it will receive, the cathode will give 2 electrons to the lead ion. So lead ions will receive 2 electrons and become lead and stick to the cathode. It will stick to the cathode. The lead molecule, the lead atoms will stick to the cathode here. Once more, lead ions will, Pb2 plus, will migrate towards the cathode. Since it is deficient of 2 electrons, lead will receive 2 electrons from the cathode. So cathode will give 2 electrons to lead, and it forms lead atoms, and these lead atoms will stick to the cathode, isn't it? So since lead ions is receiving 2 electrons, receiving electrons means it is reduction. So lead ions are reduced to lead metal. Receiving electron means reduction. Please remember, receiving means reduction. Receiving electrons means reduction. So it's a reduction reaction here. Receive electrons, reduction. R for receive, R for reduction. Now reaction at the cathode, at the anode. Now what happens? At the anode now, which ion migrate towards the anode? The anions. In this case, we have bromide ions. So bromide ions will migrate towards, the bromide ions migrate towards, they are attracted towards the anode. Now, you know that it is only the electrons that flow. Protons, they never flow. As simple as that. So, since bromide ions has one extra negative charge, Br minus. So, Br minus will lose 2 Br minus. These 2 Br minus will go, 2 bromide ions will go, and loses electrons, will lose 2 electrons that it has and becomes Br. Or we can say that, to make it simple, 1 Br bromide ion will lose, this minus means lose, over here plus means it receives. Lead ions receives, this plus over here means receives 2 electrons and forms lead metal. Over here, the lead bromide ion, the negatively charged cation, we call it, anion, will lose the extra electron it has. And where does it go? It will give it to the anode. The anode will receive. The anode will receive this electron, extra electron of bromide ion has. This extra electron is received by anode and becomes bromine atom. You know that bromine, bromine atoms are not stable. So therefore, the two bromide ions, Br minus ions, forms bromine. Now you know that bromine is a liquid non-metal. So we get, in that heat, bromine is formed here. So since bromine is a liquid, it forms vapors. Reddish brown vapors of bromine can be seen at the, or reddish brown fumes of bromine can be seen at the anode. Is it okay? Now the questions that may be asked on this is, write the reactions at the anode and the cathode. What are the products? What do you observe? And what is the crucible made of, the electrolyte made up of? What is the electrolyte? Of course, why is it in a molten state? what are the electrodes used and why, and so on. These are some of the questions that will be asked in ICSE. Okay, so these are the things that you have to remember as far as the electrolysis of lead bromide is concerned. So over here, as I told you, since there is it receives lead ions, they receive electrons from the cathode and becomes lead metal. This is reduction reaction. Okay, now over here, bromide ion is losing the electron and becomes bromine atom. So this is, since it is losing oxidation, losing electrons, this is called oxidation. So it's a very good example of redox reaction. So electrolysis of lead bromide involves the oxidation and reduction reactions at respective electrodes. So therefore, it is a redox reaction. It's a very good example of redox reaction. So that, why is graphite used now? I forgot to tell you why is graphite used as an electrode in the anode. Why is it made up of graphite? Because what is the product that is formed in the anode? It is the bromine vapors. It is at the anode, bromine is formed. So since bromine will react with other metals, it does not react with graphite. So therefore, graphite is used as an anode in this particular case. Is it okay? Why? Because it is unaffected by, graphite is unaffected by bromine vapors. Is that okay? Now we come to electrolysis of water. Electrolysis of water. What is the electrolyte? Electrolyte of lead bromide means the electrolysis of lead bromide means the electrolyte is PbBr2. Now, electrolysis of water means the electrolyte is water, H2O. This is the electrolyte. Okay, H2O. Now you know that pure water is a non-electrolyte, does not conduct electricity. So we put a few drops, not much, few drops of sulfuric acid. We add few drops of sulfuric acid in water. Now why? Because pure water is a non-electrolyte. It will not normally conduct electricity. It consists of entirely of molecules, you know that. So it can be electrically decomposed by addition of little bit of dilute sulfuric acid, so that water discharges into ions. So it is the electrolysis of not pure water, it is the electrolysis of acidified water, acidified by sulfuric acid. Now why not any other acid? Why only sulfuric acid? You got to remember that, because sulfuric acid is a non-volatile acid. It is a non-volatile acid. Why not nitric acid? Why only dilute sulfuric acid? So one of the reason is dilute sulfuric acid is non-volatile. So nitric acid is not used. Why? Because it is a volatile acid and may decompose into nitrate radical, which may tend to interfere with the electrolytic reaction. So therefore nitric acid is not used. Okay. Now two things you got to remember. As I already told you, number one, pure water is not a good conductor of electricity. That's why we add a few drops of sulfuric acid. And why only sulfuric acid? Why not nitric acid? Because sulfuric acid is a non-volatile acid and nitric acid is not used because it is number one, it's a volatile acid, and the nitrate which will be formed, which may interfere with the electrolytic reaction. Is it okay? Right. So you got to remember that the electrodes over here, the anode and the cathode. The anode and the cathode is made up of platinum. Why? Because like graphite, platinum is also very, very unreactive metal. Is it okay? It's an inert electrode. Graphite is also inert electrode. Platinum is also inert electrode. Does not take part in the electrolytic reaction. That's why we use platinum foil as the electrolyte. Now it takes place in the ordinary temperature. You don't have to heat it or somewhat like something like that. And the temperature is 3 amperes. Like over here also in lead bromide also we use 3 amperes. Here also we use 3 amperes. Now dissociation of the molecules of sulfuric acid and water. Now since we have water, water dissociates into, remember, hydrogen ions because of sulfuric acid. Usually pure water does not dissociate. So since we have added a little bit, a few drops of sulfuric acid, so water dissociates into H plus and OH minus, hydrogen ions and hydroxyl ions. Okay. Now since we have few drops of sulfuric acid, so sulfuric acid also dissociates. H2SO4 also dissociates into 2H plus and SO4 2 minus. Okay. Water dissociates into hydrogen ions and hydroxyl ions, and H2SO4 sulfuric acid, few drops of sulfuric acid which is added to water will also dissociate into H plus and SO4 minus. Now we got to remember the reactions at the anode and the reactions at the cathode. So first we will deal with the reaction at the cathode. Now we have ions, we can see, isn't it? We can see the ions. So what are the positive ions? We can see the positive ions, hydrogen ions in both the cases. And negative ions, you can see the negative ions here. The negative ions are hydroxyl ions and sulfate ions. Please remember that. Hydrogen ions and sulfate ions, hydroxyl ions and the sulfate ions are the negative ions. And hydrogen ions in both the cases are the only positive ions. So hydrogen ions will migrate towards the cathode. Cations will migrate towards the cathode. Now what happens is, since cathode is negatively charged, so hydrogen ions will migrate towards the cathode, the cations will migrate towards the cathode, and it receives, okay, is the receiving end now. It receives, hydrogen ions will receive, plus means over here, receives one electron from the cathode. So cathode will give one electron to the hydrogen ion. That means hydrogen ion will receive one electron from the cathode and becomes H. Now you know that hydrogen is unstable. Hydrogen atom is unstable. So two hydrogen ions or hydrogen ions, that one hydrogen ion which is formed here will combine with another hydrogen ion which will be formed later and forms H plus H, produces H2, which is gas. Hydrogen bubbles, you will see hydrogen bubbles will collect. Hydrogen will be collected here in the inverted test tube. Now we go to the reaction at the anode. Reaction at the anode. Now what happens? Reaction at the anode. Please remember now. It's very important here. Now both OH minus ions as well as SO4 minus ions, sulfate ions as well as hydroxyl ions will migrate towards the anode. Now which ion will get discharged? This is known as selective discharge. If you want to know about the selective discharge, and I've posted notes yesterday, you can have a look. We talk about the electrochemical series, which is on page number 110, and selective discharge is on page number 111. 110 and 111. So this is called selective discharge. So if you want to understand the electrochemical series, now when we talk about the electrochemical series, a little bit of electrochemical series here, okay, just a short explanation. In the electrochemical series, the sulfate ions is at the top and hydroxyl ions are at the bottom. Okay, in between we have nitrate, NO3 minus, then we have, I'll just refer to the book, Cl minus, chloride ions, bromide ions, and we have iodide ions or iodine ions, and then we have hydroxyl ions. Now at the top we have sulfate ions, at the bottom hydroxyl ions. So the selective discharge means over here, this is the electrochemical series. The lower one, the selective discharge will decrease towards the bottom, increase towards the bottom as we go down. So hydroxyl ions will get discharged instead of not sulfate ions. Why? Because sulfate ions is at the top, whereas hydroxyl ions is at the bottom in the electrochemical. This is the electrochemical series. The one at the bottom will get discharged. Is it okay? So since we are interested in, over here we have sulfate ions and hydroxyl ions. So hydroxyl ions will get discharged. Why? Because it is lower in the electrochemical series compared to sulfate ions. If we have nitride and bromide ions, the bromide ions will get discharged. Why? Because bromide ions is lower in the electrochemical series. If we compare nitrate and iodide ions or iodine ions, which one will get discharged? Iodine ions will get, or the iodide ions will get discharged. Why? Because iodine is lower in the electrochemical series. So those ions which are lower in the electrochemical series will get discharged. This is called selective discharge of ions. Okay. So over here, both the hydroxyl ions as well as the sulfate ions will migrate towards the anode. Because they are anions, they migrate towards the anode. Now which one will get discharged? OH minus ions will get discharged. OH minus ion will get discharged. SO4 minus ions will remain in the electrolyte, will remain in the solution. Nothing happens to it. So a reaction at the anode, OH minus ions will receive one electron. Will receive one electron and becomes OH. And becomes OH. Is it okay? Now, for OH molecules are not very stable. So, 4OH will come and combine with each other and forms water and oxygen. It forms water and oxygen. Water and oxygen. So we have to balance it. So we put 2 in the front. Okay. So what is the product? Water will go back to the electrolyte. The water which is formed here at the anode will go back to the electrolyte, and the gas which is collected is the oxygen. Over here it is hydrogen, and over here it is oxygen. So what are the products at the anode and the cathode? The product at the cathode is hydrogen gas, whereas the product at the anode is oxygen, because water will go back to the electrolyte and oxygen will be collected here. Oxygen will be collected here. Hydrogen will be collected here. So hydrogen will be collected at the cathode and oxygen gas is collected at the anode. In the ratio of 1:2. Hydrogen is to oxygen ratio will be 2:1, because it is H2O. 2 volumes of hydrogen, 1 volume of oxygen. So hydrogen is to oxygen ratio will be collection of hydrogen and oxygen will be collected at the ratio of 2:1. Is it okay? So again, this is a redox reaction, the very good example of redox reaction. Over here, the hydrogen will receive 1 electron. It will receive, so it will receive R, so therefore it is reduction reaction. So there is a loss of oxygen here, sorry, OH minus, not plus 1 electron, it is minus, okay. So hydroxyl ions will lose 1 electron and forms hydroxyl. This is oxidation reaction. So since a reduction reaction takes place at the cathode and oxidation reaction takes place at the anode, it is a very good example of redox reaction. So this is all about the electrolysis of lead bromide, molten lead bromide and water, acidified water. Remember, molten lead bromide and acidified water. Why molten? Because solid lead bromide ions are not free, so therefore they do not conduct electricity. When molten, the ions are free, so they will conduct electricity. And over here, why acidified? Because water, normal pure water, do not conduct electricity. Okay, it is a non-conductor of electricity. So acidified water, why? Because we put few drops of sulfuric acid to make sure that water dissociates into ions, H plus and OH minus ions, for the electrolysis of water to take place. So this is all about today's class. I hope you understood. If you can't grasp a few points, you can rewind and have a look at it. You will understand, I'm sure. So thank you for watching.